All right, let's take a look at the practice test. So for the instructions, we're asked to find the resultant using the triangle method. So first and foremost, when we say we want to find the resultant, or sometimes the book will say the resultant vector, this just means we're finding the sum of two or more vectors. Now, when we talk about the triangle method, this is a way to show the addition of vectors geometrically. So we're going to do this on a coordinate plane. So for problem 1, we're given this vector A, and it's in component form. So the horizontal component is -5, and the vertical component is 1. Let me make that bracket a little bit better there. Now, the vector B is also in component form. We have a horizontal component of 6 and a vertical component of -8. So what I'm going to do is come to a coordinate plane. And before I show you this stuff right here, let's just do this algebraically. It's a very simple process. So to find the resultant, or again, you could say the resultant vector. So I'm adding the vector A to the vector B. Then basically this result is going to be a vector where we just sum the horizontal components. So -5 plus 6. And then we're going to sum the vertical components. So 1 plus -8. Let's just go ahead and crank that out real quick. So this is going to be -5 plus 6 is 1. And then 1 plus -8 is going to be -7. So this right here would be our resultant vector in component form. So the horizontal component is 1 and the vertical component is -7. So how can we get this result using a coordinate plane? Well, basically, you're going to start with one of these. I'm just going to pick the vector A. You could have picked the vector B. It's really up to you. So I'm going to take this vector A, and I'm going to sketch this guy in standard position. So that means that the initial point is at 0, 0, or the origin, and the terminal point is given right here. So this is going to be -5, 1. So that's very straightforward. You shouldn't have any problems with that. Now here's where it gets a little bit tricky. You're going to take your vector B, and now instead of having an initial point at the origin, you're going to have an initial point at the terminal point for your vector A. So in other words, the initial point will be at -5, 1. Now you need to figure out where is this terminal point going to be. And the way you do that is you basically say, well, I'm at -5, 1 to start. I'm moving to the right by 6 units. So -5 plus 6 would be 1. Okay, so that's my X location. And then I'm moving to the left by 8 units. So 1 minus 8, or 1 plus -8, is going to be -7. So that's going to be my Y location. Okay, so that's my terminal point. Now, once you have that information, you basically have your resultant vector. So the way this works is that it's going to be sketched where the initial point is at the origin, and the terminal point is at that guy you just found, so 1, -7. So that's how you can figure that out geometrically. This is how you can do it algebraically. Either way, you do have to do some addition, but this is just a way you can show this, and your teacher will sometimes ask you to put this down on a coordinate plane just so you understand the concept. All right, for the next problem, the instructions are going to change a little bit. Now we want to find the resultant using the parallelogram method. So this is just another way to show this geometrically. So for problem 2, we have our vector A given to us in component form. So the horizontal component is 4. The vertical component is 5. Then we have our vector B, also given in component form. The horizontal component is 6. The vertical component is -8. Okay, so coming to the coordinate plane, again, I'm just going to paste this in. And I'll just perform this operation now just to get it out of the way. So the resultant vector, again, if I do the vector A plus the vector B, let's go ahead and say it's going to be the horizontal components being added together. So 4 plus 6. And then the vertical components being added together. So 5 plus -8. Let's close that down. So let's crank this out real quick. 4 plus 6, we know that's 10. 5 plus -8, that's going to be -3. So how do we use this parallelogram method? It's a little bit different than what we just saw, but you get the same result. So basically, you're going to sketch vector A and vector B in standard position. So in each case, the initial point is at the origin, or 0, 0, and your terminal point is given here, right? So for the vector A, the terminal point is here. So this is at 4, 5. For your vector B, the terminal point is here. So this is 6, -8. So the main thing is you're going to take this side right here and basically slide it down to create this side right here. And maybe I should have done that in a lighter color so it shows up better. And then you're going to take this side right here and slide it down to create this side right here. So the main thing is once you've created those sides, you just need to find this point right here. And again, you can always do that with this addition. If I'm starting here, and I want to sketch this guy right here, well, all I need to do is say, well, it's going to be 4 plus 6, or 10. and then 5 plus -8, which is -3, right? So you're just going back to this simple addition to get this guy right here. So you get this point that allows you to create this side and this side. So you complete the parallelogram, and then this guy right here, this is going to be your resultant vector, okay? Now, the other way you could have done this, again, you could have sketched your vector A, and then you could have sketched your vector B like this, and you see that you would have ended up with the same result. You also could have done this a different way. So let's say that you chose to sketch vector B first, and then you sketched vector A. Well, again, here's your resultant vector there. So however you want to do this, there's lots of ways to show this graphically. It's very easy to do algebraically. Our resultant vector here, the component form, the horizontal component is 10, and the vertical component is -3. All right, for the next few problems, we're going to change the instructions up. Now we're going to find the component form of the resultant vector. For problem 3, we have 2 that is multiplied by the vector f plus 6 that is multiplied by the vector b. So you have your vector f that's given in component form. You have a horizontal component of -3, a vertical component of 9. You have your vector b, which is also given in component form. You have a horizontal component of -7 and a vertical component of -1. Okay, so if we want to find 2 multiplied by the vector f, then plus 6 multiplied by the vector b, what do we do? So first, I'm going to deal with this scalar here. So this 2 that's being multiplied by the vector f, you're just going to end up multiplying 2 by each component. So let me show this fully. So I'm going to put a 2 out in front of this vector. So you have -3 and 9 as the components there. Let me put a plus sign. You're going to have this 6 that's going to multiply each of these components in your vector b. So let's put this 6 out in front. And let's put -7 and then -1 inside here. Let me put an equal sign here. And I'm going to drop down just a little bit. So basically, to show this fully, I'm just going to say that it's going to be 2 times -3, and then 2 times 9 inside. You don't need to do this each time. You can just do it mentally, but just for the sake of the tutorial, I'm just going to show all the steps. So then for this one, I'm going to go 6 times -7, and then 6 times -1 like this. So let's say this equals, you're going to have 2 times -3, that's going to be -6, and then 2 times 9 is 18. And then plus over here, 6 times -7 is -42. And then 6 times -1 is -6. So now we've gotten this into a form that's pretty easy to work with. We know that if we have one vector plus another vector to find what we call the resultant or the resultant vector, you're going to add the horizontal components. So -6 plus -42, that's going to be -48. And then we're going to sum the vertical components. So 18 plus -6, that's going to give me a positive 12. So the resultant vector here in component form is going to have a horizontal component of -48 and a vertical component of 12. Okay, let's look at problem number 4. So we have 9 times the vector u plus 8 times the vector b. So I'm going to go a little bit faster on this one because it's a very simple concept overall. You have your vector u given in component form. The horizontal component is 3. The vertical component is -10. Again, the vector b, also given in component form. The horizontal component is -11, and the vertical component is -5. So to set this up, let's go 9 times the vector u plus 8 times the vector b. This is equal to, let's put a 9 out in front of this guy right here. So your components, you have 3 and then -10. And then let's go plus. You're going to put an 8 out in front of this vector here. So for the components, again, -11 and -5. So I'm going to go a little bit quicker like I just mentioned. I'm not going to put this inside. I'm just going to think about, okay, 9 times 3 is going to be 27. And then 9 times -10 is going to be -90. And then plus 8 times -11 is going to be -88. And then 8 times -5 is going to be -40. Okay, at this point, what you want to do is add the horizontal components. So 27 plus -88, that's going to be -61. And then add your vertical components. So -90 plus -40, that's going to be -130. So this is my resultant vector. And basically in component form, the horizontal component is -61 and the vertical component is -130. All right, let's take a look at problem number 5. So we have 5 times the vector f plus 5 times the vector v. So for the vector f in component form, we have a horizontal component of -5 and a vertical component of 1. And then for the vector v in component form, we have a horizontal component of 2 and a vertical component of 12. So let's say that 5 times the vector f plus 5 times the vector v is equal to, I'm going to put a 5 out in front of this, so a 5 out in front. So you have -5 and then 1 as your components. And then you have a plus sign. I'm going to put a 5 out in front of this. So the components, you have 2 and then 12. So again, I'm going to go a little bit quicker here. I think we know at this point that the 5 is going to be multiplied by each component here, and the 5 is going to be multiplied by each component here. So 5 times negative 5 would be negative 25, and then 5 times 1 would be 5. Then plus 5 times 2 would be 10, and then 5 times 12 would be 60. Okay, so we got this far. Now what do we do? Well, if we're trying to add these two vectors together, basically you add the horizontal components. So negative 25 plus 10, that's going to be negative 15. Then you add your vertical components. So 5 plus 60, that's going to be 65. So the resultant, or again, the resultant vector, if you want to say it that way, we're going to have this in component form where the horizontal component is negative 15 and the vertical component is 65. Okay, let's take a look at problem number 6. So here we have negative 4 times the vector u, then minus 9 times the vector v. Now, a lot of times if I see subtraction, I'll just change it to addition of the opposite. It's perfectly legal. You have your vector u here. In component form, you have a horizontal component of 11 and a vertical component of 6. Then you have your vector v also in component form. So the horizontal component is 2 and the vertical component is negative 5. So let's say that we want negative 4 times the vector u. Then I'm going to go plus negative 9 times the vector v. And you can go minus if you want. I just like to do plus negative. So let's go ahead and say this is equal to, I'm just going to stick a negative 4 out in front of this vector here. So you've got 11 and then 6 as the components. So now I'm going to go plus, because I've written this as addition of the opposite. This guy is going to be negative 9. And then I'm going to set this up with these components here. So 2 and then negative 5 inside. So all I'm going to do now is just multiply negative 4 times 11. That's going to give me negative 44. And then negative 4 times 6, that's going to give me negative 24. So that part's done. Then I have my plus. So I'm going to go negative 9 times 2. That's going to give me negative 18. And then I'm going to go negative 9 times negative 5. That's going to give me 45. So at this point, we're going to add the horizontal components. So negative 44 plus negative 18, that's going to be negative 62. And then negative 24 plus 45, that's going to be 21. Okay, so my resultant, or again, the resultant vector, if you want to say that, in component form, the horizontal component is negative 62, and the vertical component is 21. Okay, let's take a look at problem 7. So here we have negative 2 times the vector f, then minus 9 times the vector g. So we have f given to us in component form, where there's a horizontal component of 5 and a vertical component of negative 7. We have g in component form, which is given to us where negative 6 is the horizontal component and negative 6 is also the vertical component. So let me write this out. We have negative 2 times the vector f. And then what I'm going to do is put this as plus negative. I just think it makes it a little bit easier. So I'm going to go plus, and then you could wrap this in parentheses if you want for clarity. So plus negative 9 times your vector g. So to set this up, let's go ahead and say that we have negative 2 out in front of this guy right here. So the components inside, you have 5 and then negative 7. And then we're going to go plus, you're going to have negative 9. And then inside here, you're going to have negative 6 and negative 6 as your components. Okay, so let's put equals here. I'm going to multiply negative 2 times 5. That's going to give me negative 10. And then negative 2 times negative 7, that's going to give me 14. Let's close that down. Then I have plus. Negative 9 times negative 6 is going to be 54. And it's going to be duplicated here because you have the same thing. So let's just put a 54 here as well. So let's come down here a little bit, and I'll say this equals. To finish this up, let's add the horizontal components. So negative 10 plus 54, that's going to be 44. Let's add the vertical components. So 14 plus 54, that's going to be 68. So in component form, my resultant, or once again, if you want to call it the resultant vector, the horizontal component is 44 and the vertical component is 68. All right, let's take a look at problem 8. So here we have 4 times the vector a plus 5 times the vector v. So vector a is given to us in component form where the horizontal component is 12 and the vertical component is negative 7. Then vector v is given to us in component form where our horizontal component is 10 and the vertical component is negative 8. So let's write this out. We have 4 times the vector a, then plus 5 times the vector v. This is going to be 4 times this guy right here. So you have 12 and then negative 7 as your components. And then plus, you're going to have 5 times this vector v. So you're going to have 10 and then negative 8 as your components. So let's say 4 is going to get multiplied by each one of these components. So this would be 4 times 12, that's 48. And then 4 times negative 7, that's going to be negative 28. Then plus, you're going to multiply 5 by each component here. 5 times 10 is going to be 50. And then 5 times negative 8 is going to be negative 40. Okay, for the final step here, you're going to add the horizontal components together. So 48 plus 50 is going to be 98. And then you're going to add the vertical components together. So negative 28 plus negative 40, that's going to be negative 68. So my resultant, or once again, the resultant vector, if you want to call it that, in component form, the horizontal component is 98, and then the vertical component is negative 68. Okay, let's take a look at problem number 9. So here we have the negative of our vector u, then minus our vector b. Now we're not given the component form for the vector u, and we're not given the component form for the vector b. So we need to figure that out first before we can do this. So we're given the magnitude of the vector u. We're told that that's 10. We're given the direction angle for the vector u. That's going to be 184 degrees. Let me just copy this real quick and come down here. And remember, if you want to find the component form of the vector u, for the horizontal component, you take the magnitude, which is 10, and you multiply by the cosine of that direction angle, which is 184 degrees. Then if you want to find the vertical component, again, you take the magnitude, which is 10, and now you multiply it by the sine of that direction angle, which is 184 degrees. Okay, let's go back up. We're going to get the other guy. So for this one, the magnitude of the vector b is going to be 14, and then the direction angle theta is going to be 304 degrees. So let me copy that real quick and come down here. So for the vector b in component form, the horizontal component, again, just take this magnitude here, which is 14. Let me actually just put it there as well. So then here it's times cosine of the direction angle, which is 304 degrees. Here that magnitude is times the sine of, again, that direction angle, which is 304 degrees. All right, now before we continue, if you wanted a super accurate answer, then you could continue with things in this form and just round at the end. Okay, I'm not going to do that. And so the answer I get is going to be slightly different than the practice test. So it's really not that big of a deal for your self-studying. If you're in a course and they're teaching this, you just need to ask your teacher what they want you to do, how accurate do they want your answer. So let's come back up and figure out what we need. So the negative of the vector u and then minus the vector b. So let me copy that and let's come down here. And I'm just going to paste this in here. So if you go 10 times the cosine of 184 degrees, let's say that's about, we'll go negative 9 point, let's just go ahead and say 98. Okay, so I chose to round to the nearest hundredth. You might choose to round to something else. Again, it's really up to you. So then the other guy, let's go 10 times the sine of 184 degrees in the calculator. I'm going to round that to the nearest hundredth and get about a negative 0.7. So let's say this is negative, I'll put 0.7 like this. Okay, so I put equals here. We know this is an approximation. You can use the approximately equal to symbol. It's really up to you. Again, if you're self-studying, it's not that big of a deal. So down here, let's go 14 times the cosine of 304 degrees. And if I round that to the nearest hundredth, I get about 7.83. So let's say 7.83. And then 14 times the sine of 304 degrees. Let's say that's negative 11.61. At this point, all I'm going to do is say that I want the negative of my vector u. And you can go plus negative 1 times the vector b, or you can just leave it as subtraction. It's up to you. Here it's pretty easy. Let's leave it as subtraction for once. So let's put minus the vector b like this. So what is this going to be? If you have a negative in front of something, you can treat that as just negative 1, right? So let me get rid of this, and I'm just going to put a negative 1 out in front of this vector here. So you have negative 9.98, and then you have negative 0.7. Let's close that down. And actually, let me drop this down because it's not going to fit over here. And I'm just going to put this like this. So you have your 7.83, and then your negative 11.61 like this. Okay. So what is this going to give me? Let me put equals here. So you're going to basically multiply each component here by negative 1, which is just a fancy way of changing the sign. So this right here would be positive 9.98, and this would be positive 0.7, or we could go 0.7 to stay consistent. And now you have minus, here you have 7.83, and then here you have negative 11.61. Okay, so far so good. What I'm going to do at this point is just subtract this guy minus this guy. Okay, so I'm going to go 9.98 minus 7.83. That's going to give me 2.15. And then here's where you have to be careful. You have 0.7 and then minus a negative 11.61. So let me write this out. 0.7 minus a negative 11.61. We know minus a negative is plus a positive. So this is like me doing this addition here. That's why I like to convert these things over to addition of the opposite. It just alleviates a lot of the sign mistakes. So let's go ahead and go 0.7 plus 11.61 in the calculator. And I'm going to get 12.31. So this would be my resultant vector in component form. The horizontal component is 2.15. The vertical component is 12.31. Now, if you are on the practice test, you may notice that this guy right here is slightly different, right? On the practice test, it's listed as 12.3. And again, this is just because the computer solved it in a different way. It's going to give you a more accurate answer. So either way, if you're self-studying, just get something that's close enough. If you're in a course, just ask your teacher, hey, where would you like me to round to, or what steps would you like me to take when I'm solving this problem so that I get the same result as you? Okay, let's take a look at problem number 10. So here we have 8 times the vector f minus 8 times the vector b. And you see we have the same setup as last time. So what I need to do is figure out, let me come down here, my vector f in component form. So this equals what? And then my vector b in component form. So this equals what? Okay, so we know that it's the magnitude times the cosine of the direction angle for the horizontal component, and then the magnitude times the sine of the direction angle for the vertical component. For the magnitude of f, it's 12. For the direction angle, it's 24 degrees. So this is going to be 12 times the cosine of 24 degrees, and this is going to be 12 times the sine of 24 degrees. So for this one, I get about, let's say 96. So 10.96 rounding to the nearest hundredth. And for this one, I get about 4.88 if I round to the nearest hundredth. So let's put that there. And again, I'll just say that if you're self-studying, you can put equals there. It's no big deal. But your teacher may want you to put an approximately equal to there. So that's really going to be up to you. So then for this one right here, let's go back up. For the magnitude of the vector b, it's 18. And then for the direction angle theta, it's 52 degrees. So this is 18 times the cosine of 52 degrees. This is 18 times the sine of 52 degrees. Let's key this into the calculator. So here, if I round to the nearest hundredth, I get about 11.08. And then here, I get about, let's say, 14.18, again, rounding to the nearest hundredth. Okay, so coming back up, I want 8 times the vector f, then minus 8 times the vector b. Let me grab this real quick. And we'll come down here and just paste this in. And I'm going to convert this over to plus a negative there. So actually, let me write this a little bit better. So plus, you'll have negative 8 times your vector b like this. So this would be 8 times this guy right here. So you have your 10.96, and then your 4.88 as your components. And then you'd have plus, you have your negative 8, and then times this guy. So you're going to have your 11.08, and then your 14.18 as your components. So let's put equals here. 8 times 10.96, that's going to give me 87. Let's say 68. Maybe make this 7 a little bit better here. And then 8 times 4.88, that's going to be 39.04. Let's put plus here. Negative 8 times 11.08, that's going to be negative 88.64. And then negative 8 times 14.18, that's going to be negative 113.44. Okay, so pretty easy at this point. We're just going to add these horizontal components. So 87.68 plus negative 88.64, that's going to give me negative, let's say 0.96. Then we're going to add these vertical components. So 39.04 plus negative 113.44, that's going to give me negative 74.4. Now, if you're on the practice test, again, because of rounding, the answer is slightly different. So you're going to get negative 0.95 there. Okay, so very close. And then negative 74.43 there. Okay, so this answer is fine. Again, when you use a computer for this, it's going to be more accurate. So the component form that we found, the horizontal component is negative 0.96, and the vertical component is negative 74.4.